Now, in what follows, we shall make a few critical comments on Popperian methodology as well, which has as many detractors as admirers. Popper draws an invidious distinction between the context of discovery and the context of justification, and maintains that philosophy of science as methodology of science must confine to the context of justification without dwelling upon context of discovery. He refuses to say anything about context of discovery, only he tried to provide the context of, he tried to dwell upon the context of justification. Why? According to him, according to Popper, discovery process, the process of discovery involves rational factors which defy, irrational factors. I am not telling you irrational factors, but irrational factors which may be rational, may not be rational, okay, factors which defy any kind of rational explanation. His rejection of the possibility of a rational account of discovery has been called into question. He seems to confine his attention to the examples of Kekule's discovery of benzene structure, wherein the central idea occurred to Kekule in a dream. This is the context of discovery perhaps did not catch the attention of Popper, only context of justification he was referring to. But not all cases are standard. Typical discoveries are provided by an elaborate reasoning capacity, reasoning processes. Even in the case of Kekule, one must explain why only that dream was taken as providing clue to the benzene structure. It appears more plausible to say that Kekule had undertaken enough reasoning to get the hint from that dream. That is to say, though clicks, hunches, intuition and other imponderables do play a role in the formation of hypothesis, they are preceded and succeeded by a long and guided chain of reasoning. Perhaps the main reason for Popper's rejection of the possibility of a rational account of discovery is his identification of the possibility of a rational account of discovery with the possibility of an inductivist account of discovery. Then what is that inductivist account of discovery? Inductivist account of discovery maintains the use of the principle of induction coupled with repeated observations leading to discovery. Later, inductivists like John Stuart Mill even tried to work out thumb rules of discovery. Popper is right in showing that inductivists came nowhere near providing an account of discovery. No amount of observations can suggest as a theoretical idea, but Popper is wrong in thinking that from this it follows that a rational account of discovery is an impossibility. N.R. Hanson in his patterns of discovery comes heavily on Popper and advances a theory concerning discovery on the basis of the work by Charles Peirce. If according to Popper the essence of science consists in the way in which theories are tested, according to Hanson, real science is over with the conception of the hypothesis. If you make conjecture, if you make hypothesis, if you formulate hypothesis, then there is no place of real science for N.R. Hanson. Because why? Because conjectures, hypotheses, they are not a part of the real world according to N.R. Hanson. To quote, let me quote N.R. Hanson, okay, from his book Patterns of Discovery. Okay. There is something wrong with the HD account, hypothetico-deductive account. If it were constructed or if it were construed as an account of physical practice, it would be misleading. Physicists do not start from hypothesis, they start from data. Though not in the inductivist fashion, by the time a law has been fixed into the hypothetico-deductive system, really original and physical thinking is over. The pedestrian process of deducing observation statements from hypothesis comes only after the physicist sees that the hypothesis will at least explain the initial data requiring explanation. Responding to Popper's contention that the context of discovery is irrelevant from the methodological point of view, Hanson says that Galileo struggled for 34 years before he was able to advance his constant acceleration hypothesis with confidence. Is this conceptually irrelevant? Was it only the predictions from his hypothesis which commended to Galileo? The philosopher of science must answer no. The kind of debate which N.R. Hanson in his patterns of discovery raised, the kind of debates he raised that shows us how not only context of justification, but also context of discovery is important, and whether it is important or not, that is also a secondary question. The primary question, is it possible to provide a rational account of the context of discovery, okay, which Popper negated. Popper said no, it is not possible to provide a rational account of discovery, rather it is absolutely impossible, rather we must only talk about context of justification as a methodological rationale. But for Hanson, as a critique to Popperian methodological schema, okay, he questioned that no, it is not impossible to provide a rational account of the context of discovery. Okay. Discussing in detail the process by which Kepler arrived at his final position, Hanson concludes, Kepler never modified a projected explanation capriciously. He always has a sound reason for every modification he made. When exactly satisfied, the observations it stood upon a totally different logical footing from what it would if it has been struck out at random and has been found to satisfy observations. Kepler shows his keen logical sense in detailing the whole process by which he finally arrived at the true orbit. This is the greatest piece of retroductive reasoning ever performed. The type of reasoning that we are talking about, which has gone into the thinking of Kepler, Hanson characterizes as retroductive. The form of the inference, okay, is number one, some surprising phenomenon P, I am just using P for phenomenon, is observed. Phenomenon P would be explicable as a matter of course if a hypothesis H is true, and hence there is a reason to think that H is true. If P is observed, if P can be explicated as a matter of course, if hypothesis is true, H is true, in such circumstances, okay, there is a reason to think that even your hypothesis is true. Hypothesis does not emanate from some unaccountable creation as hypothetico-deductivists think, nor from simple repetitions of observations as inductivists think. Okay. Hanson tried to give a rebuff to both inductivist schema that only simple repetitions of observations or simple repetitions of observations are responsible for knowledge generation, or Hanson also gave a rebuff to the way hypothetico-deductivists think hypothesis does not emanate from some unaccountable creation. Okay. In fact, hypothesis emanates from a mode of thinking which seeks to find out a plausible pattern into which what are observed are fitted. If I tell you what is, going back to what is a hypothesis, a tentative solution to a problem or hunch, we always try to provide a causal relationship, a cause and effect relationship. In that causal relationship, what we try to do, suppose if I give you an example, I will say population problem is the cause of underdevelopment, or I can also say underdevelopment is the cause of population problem. We are trying to find out a plausible pattern in which they are observed, in which they can be fit into the system. Okay. This is how Hanson tried to bring about a critique to Popperian methodology. Thus, a hypothesis provides such as a plausible pattern. Before we test a hypothesis, it must at least be plausible and not just a conjecture. Of course, that is why whenever we say that we must formulate a hypothesis, we have to bank on literature, we have to bank on many other earlier works, many other earlier observations, data and so on. Okay? We just do not make a hypothesis in a random manner. Of course, apart from its plausibility, okay, the hypothesis must satisfy further conditions, okay, such as if a hypothesis H is meant to explain a phenomenon P, then H cannot itself rest upon the features in P which required explanation. That is why the peculiar color and odor of chlorine are not explained by reference to atoms in a volume of chlorine, each one having the color and odor in question H or hypothesis. Okay. Grasping this point is essential for any understanding of the fundamental concepts of modern particle physics. Okay. Of course, the current work on discovery has gone much ahead of Hanson in terms of sharpness of articulation and rigor of analysis, but the credit of putting on defensive the Popperian position on discovery goes to Hanson's path-breaking work in the patterns of discovery. Another serious lacuna in Popper's position concerns his idea of scientific progress. The progress of science is continuous in the sense that in two successive theories, the latter contains the former or the best part of it. The continuity of scientific progress is exemplified by the fact that between two successive theories, the former is always the limiting case of the latter. Okay. In this connection, Popper cites the example of Newtonian theory and Einsteinian theory. Okay. But it is not always the case. But Popper first overlooks the fact that in the actual history of science, such comparables are rare. That is why I said this is always not the case. Okay. For example, it is assured to say that phlogiston chemistry is the limiting case of oxygen theory, or polemic theory is the limiting case of, Ptolemaic theory is the limiting case of Copernican theory. Okay. The one existing theory and a better theory. Okay. If I say phlogiston chemistry is the limiting case of oxygen theory, or Ptolemaic theory is the limiting case of Copernican theory. Ptolemy, as I said in the context of astronomy, which when he suggested that the sun moves round the planets including the earth, and the planets including the earth do not move, they remain constant. Okay. Okay. Ptolemy's Ptolemaic theory is the limiting case of Copernican theory, Copernican revolution. Okay. And secondly, Popper's idea that our successive theories exhibit increasing degree of verisimilitude, I mean closer to the truth, is more like what our present theory says than what our earlier theory indicated. It implies that following Popper, we must say that the ultimate constituents of matter are more like fields such as contemporary physical theory indicates than particular as classical physics indicated. Okay? I mean, I repeat, I must reiterate that the ultimate constituents of matter are more like fields than particular fields. Okay? But this is slightly unintelligible. In short, we are led to unintelligibility if we literally apply Popper's characterization of two successive theories to the very cases he takes to be paradigmatic. Okay? And finally, in characterizing the old theory as an approximation to the new one, Popper assumes that the general locations of the new theory imply the same things as in the old one. That is to say, Popper assumes that when a fundamental shift in theory takes place, okay, the meaning of the terms remain invariant. Okay? They do not vary. This assumption has been called into question by some philosophers of science who show that the terms like mass, force, etc. have one meaning in Newtonian framework and another in the post-Newtonian framework. For example, Thomas Samuel Kuhn and Paul Feyerabend, okay, whose views will discuss in the following lectures, okay, have convincingly argued that a shift from one theory to another is accompanied by a shift in the meaning of the works that are common to both the theories. If so, Popper's characterization of growth of science as continuous collapses. Okay? I mean, what we have discussed in this lecture. Okay? What have we got? What have we learned? Okay? As we started with methods of science, having discussed the ontological questions as well as the normative structure of science, we came to the methods of science and we made a leap from the goal of science to the method of science, from the objectives of science, but how are these objectives met with the methods of science, to the methods of science. Okay. Methods are important, very important to meet the objectives. And there we have discussed inductivism, hypothesism, positivism, and the methodology, the systematic falsification as propounded by Popper. Very quickly, we will see what kind of steps that Popper follows. Okay? Very quickly, Popper starts with step 1, identification of a problem. Okay, I'll just go back a little. I mean, as inductivists said, no, we must start with observation, then observation without recourse to any theory, then tentative generalization, which we must verify, thirdly conclusion. Okay. Hypothesists claimed that no, we must start, science must start with a hypothesis, okay. Then a tentative solution to a problem or hunch must be provided, I mean hypothesis, I mean must be provided, that it must start with a hypothesis, then hypothesis must be tested right or wrong. If it is tested right, then it must be accepted. If it is tested wrong, then the hypothesis must be rejected. Okay. In the positivistic schema, science also starts with observation. Then the premise number 1 suggests that it must start with, I mean from observations we come to a set of laws. The premise number 2 suggests that we must have a set of statements describing the initial conditions, and then we must arrive at an explanation, I mean a statement describing the phenomenon to be explained. Okay? Where this is about inductivism, hypothesism and positivism. Okay? For Popper, science must start with a problem, with a question. To address that question, we must suggest a hypothesis which is a tentative solution to a problem or hunch. I mean, to address a particular research question, one must have a hypothesis for Popper. But as hypothesists argued that no, science must start with a hypothesis, Popper rejected. Popper said no, science must start with a problem. If you do not have a problem, what kind of hypothesis you are going to formulate? Perhaps for this reason, he had in his mind that we must be able to identify a research problem, research question. Once the problem, the research problem is identified, then we must formulate our hypothesis. We must suggest a hypothesis. Okay? And that hypothesis, as in the hypothesis schema, was subject to tests. Here also it is in the context of Popperian schema also it is subject to tests, but in the not to prove or disprove or to accept or reject. Okay? But those hypotheses must be evaluated on the basis of systematic falsifiability. The method must be systematic falsification, as in the unlike in the context of positivism, what we were doing systematic verification. Okay? As positivists argued that the hallmark of science consists in the fact that all scientific statements must be systematically verifiable, and Popper replaces verifiability with falsifiability. That is why when a hypothesis is tested, not to verify but to falsify, and such systematic falsification may result in at least it may result in the form of the way a particular hypothesis may be tested right or may be tested wrong. If it is if it is falsified, if it in the process of by the method of systematic falsification, if a hypothesis is tested wrong, then it is subject to refutation. It must be refuted, and if through the methodology of systematic falsification a hypothesis is tested right, we are not going to accept it permanently as in the case of hypothesis schema, but we are going to keep our hypothesis permanently tentative, it is subject to corroboration. Then that is why in the logic of scientific discovery, in the conjectures and refutations, Popper critically evaluate, Popper tried to provide a robust structure on the methods of science by mentioning that systematic falsification may lead to refutation in the case of, if the hypothesis is tested wrong, and systematic falsification may lead to corroboration if a hypothesis is tested right. Under what limiting conditions you are going to keep you are going to test your hypothesis to be right, not under all conditions, because we are also not aware of all conditions. Okay? All conditions are not known to us, and in this case and in this sense, science is unique, science is supreme, precisely because science is an inquiry, science is a method, science is a subject area which has taught us the way we must understand the relative ways to understand any particular phenomenon. Science does not teach us to follow absolutism. Science always teaches us how to follow relativity, relative wage. That is why in theological stage, if you see that the proponents of theology or the proponents of metaphysics, they used to say that truth is absolute, knowledge is absolute. Okay? But in the context of science, at least in the Popperian schema, okay, perhaps positivists also said that no, science is absolute. Okay. But though that they also provided that space that no, this absolutism can be questioned, whereas Popper went ahead further that no, science also is not absolute, it is also relative. Okay. In this context, okay, this is very important that we must remember that no, science can never be, or any subject matter. I mean, we are not talking about, or we are not trying to attribute, okay, absolutism to any particular phenomenon as the proponents of theology or the proponents of metaphysics do. Okay. This is why science is unique and supreme. This is why inductivists, hypothesists, positivists, Popper, even later on we will find that even Kuhn and Feyerabend, they always felt the need, an urgent need to make a demarcation between science and non-science. It is very important to understand this. Okay. Then what we are going to do in the lectures to follow, we will try to look at how Popper was also questioned by Kuhn, and subsequently we will also find how all these historical traditions, so far as the methods of science are concerned, they were also challenged by Paul Feyerabend later on. But for the time being, please remember that we are not going to and let me also say that it is not that it is the end of these debates. Okay. So, if you feel that with Feyerabend we are going to have the last word, no, it is not the case. Our job is not to find out only different methods. Our job is to find out, to know, to understand the context in which these methods have emerged. These methods have not emerged as an autonomous manner, as an isolated activity. These methods are deeply socially, culturally, economically and politically embedded. This social, political, economic, cultural and institutional and ideological embeddedness of such methods with the goals and imperatives of science must be understood. That is why we started with ontological questions, then ethos of science, then from within ethos of science we tried to look at goal of science and imperatives of science. That is why we said when the goal of science is the extension of certified knowledge, the imperatives of science derive from goal and its technical methods, and there we discussed goals of modern science in the form of the ethos of science. Then we moved to the methods of science. If methods of science will be an independent exercise, then I think it is erroneous. It has some critical errors, grave errors. We must be able to examine methods of science in relation to the ethos of science, or in relation to the objectives of science, the goals of science, okay? The instrumental rationality which science has always propagated. Okay? This is what we are trying to do. Okay? Then what we did, that the way Popper tried to start with the central question of philosophy, the problem of cosmology. The problem of cosmology is the problem of understanding the world, including ourselves as part of the world. There he there he started the discussion on context of justification and refused to say anything about the context of discovery, okay, because he thought that no, context of discovery, it is not possible to provide a rational account of context of discovery. That is why he only dwelt upon context of justification, how you are providing justificatory models for your explanations, that you make, and then Popper astutely provided certain steps of scientific method. Okay? Problem identification, suggestion of a hypothesis, systematic falsification, and that systematic falsification may lead to refutation or corroboration. And then we have provided certain examples through which, okay, you can identify, you can learn the differences between inductivism and positivism on the one hand and hypothesism on the other. It is very important to know. Okay? Inductivism and positivism on the one hand and Popperian methodology on the other. From here onward, we will see whether there is any method which goes beyond systematic verification and systematic falsification as well. We will see in the context of Thomas Kuhn in the lectures to follow. Thank you.